In this video, we will talk about performance analysis of algorithms. There are various criteria to judge an algorithm's performance, such as does the algorithm do what we want it to do? Does it work correctly according to the original specification of the task? Can we know how to use and how it works? That is there documentation available that describes the algorithm? Is the code readable? These criteria are important specifically for large software systems. But there are other criteria for judging the algorithm based on their performance with respect to the computing time and the memory requirements. That is, the space complexity and the time complexity. Ideally, what we want is the fastest possible algorithm for the problem we solve. The concept of algorithms is central to computing. We need an analysis tool to measure the goodness of an algorithm. Let us look at real-world scenarios. We have a stopwatch so that we can measure the amount of time taken to complete a task or some work. In the same way, we can use scale to measure the distance, or we can have a speedometer to measure how fast a car is moving, as well as we can have monitor to measure the blood pressure. Similarly, we need a tool to measure algorithms. When an algorithm is executed, it uses CPU to perform operations and memory to hold the program and data. An analysis of algorithm refers to the task of determining how much computing time and memory is utilized by an algorithm. Analysis means to study the algorithm and determine the runtime of an algorithm. Determine maximum memory space needed for the data. Determine total size of the algorithm or the number of instructions. And determine whether the algorithm correctly computes the desired result. As part of the algorithms, we are actually concerned with the running time and space needed to execute an algorithm. Analysis plays a key role in process of designing and implementing algorithms. Therefore, we perform analysis of algorithms to compare different algorithms for the same task, to predict the performance of the algorithms, that is, how quickly an algorithm can give the results, and provide guarantee that the algorithm executes, to know how much time and amount of resources an algorithm takes to complete the task. So, to analyze algorithms, we need to have scientific basis for understanding the performance of algorithms, and using the mathematical models, we can predict the performance of algorithms or find the complexity of algorithms. At this point of time, I suppose after hearing about the analysis of algorithms, you might be wondering why all this analysis, or what is the use of analysis, because computers are getting faster and having more memory compared to olden days, where computers had less memory and slow computational power. I can argue, or the answer is, as the computers are getting more powerful, at the same time, even the data is getting significantly larger. For example, Facebook had thousands of users in 2005, and now Facebook has millions of users. So it's not the computational power, even the data is getting larger and larger. But anyways, the algorithm needs to be faster and efficient. So we measure the performance of algorithms using two techniques, that is space and time complexity. The space complexity is the amount of memory used by the algorithm during its execution. The time complexity is the amount of time taken by an algorithm to execute. Having talked about the definition of space and time complexity, we will now discuss the ways of measuring the performance of algorithms. There are two ways of measuring the performance of algorithms with respect to space and time complexity. That is, priori estimates, also known as theoretical analysis, and posteriori testing, also known as experimental analysis. In posteriori testing or experimental analysis, the runtime of an algorithm can be measured by executing the algorithm on various inputs. That is, recording the time spent on executing an algorithm. Since several or most of the high-level programming languages provide some sort of time function through which the lapse time can be computed from start till the end of the algorithm. But performing posteriori testing or experimental analysis has some limitations or disadvantages in predicting the runtime of an algorithm. First and foremost is only limited inputs can be given to the algorithm. We cannot test the algorithm with every possible input. The other disadvantages are the dependencies, such as the experiment should be performed on the same hardware and software environments. That is, what hardware we are using, the CPU, memory, cache, and the software, that is, the compilers, interpreters, and garbage collectors used, and also the operating system, network, and other applications running along in the system. Though this method is easiest compared to the theoretical analysis, but all these limitations or dependencies affect the precise prediction of runtime of an algorithm. The posteriori testing or experimental analysis gives us the idea of how to predict the performance, that is, the runtime of an algorithm, but doesn't help in understanding the algorithms. The other method is priori estimates or theoretical analysis, that is also known as the mathematical model. In theoretical analysis, the analysis is performed directly on the description of the algorithm, the operation, and the actual program or the function. The advantage of priori estimates or theoretical analysis is that it is independent of the hardware, that is the CPU, memory, cache, or the software, that is the compilers, interpreters, and garbage collectors. The priori estimates or theoretical analysis is also independent of the operating system and the other applications running along in the system. The priori estimates or theoretical analysis also takes into account all the possible inputs and characterizes runtime as a function of the input size, that is n.